Hello, welcome back. In the last video, I started to tell you a story of the internet, and we got into some of the history of the internet. And we were just about to talk about HTTP and how it's this great standard protocol that computers can use to send documents back and forth between each other, and this is the backbone of the internet. And this is going to have a lot of bearing on what makes a good REST API, hence it being very important for us in this course. But before we can continue with the story, I believe that it will be of tremendous value to you to understand what is an RFC. I feel like as engineers, we often take the tools that we use for granted. For example, we write code with Python, and we use Python to make requests across the internet to APIs, and we use browsers to request web pages, and those web pages are written in HTML, and they're styled with CSS. And the computers we use find each other using IP addresses, speaking to each other over the network, often using a standard protocol called TCP. All of these technologies that I just listed were invented by somebody. They didn't exist at one point, and today they do. And between the time that they came into existence to today, they've undergone a lot of changes. These are some of the most foundational, important creations of this day in which we live. They make the worldwide internet possible, and they also make software development at scale possible. And so, have you ever wondered who invented these things? Like, who invented JSON, and who invented HTML and HTTP? The answer to that is RFCs. And I think there's a lot of reasons why it's important for you to understand how RFCs work. And one of the biggest reasons is so that you know what information to trust when you're learning about any tool. And as we're going to see in future videos, there's a lot of disagreement on what constitutes correct restfulness when we're talking about building RESTful APIs. For better or worse, there remains a lot of ambiguity on what correct even means with respect to a RESTful API. And RFC documents are going to be core to that discussion. So without further ado, let's get into this topic. RFC is short for Request for Comments, and they are plain text documents proposing standards, usually in the form of technical specifications. In 1986, it became apparent pretty early on that for something like an internet to work, there were going to have to be some standards. For example, standard protocols for computers to exchange bytes between each other. Tim Berners-Lee helped found the IETF, which is short for the Internet Engineering Task Force. It's the premier standards development organization for the internet, and it makes voluntary standards that are often adopted by internet users, network operators, and equipment vendors. But the IETF does not control the internet. So for example, the Internet Engineering Task Force might be the group that publishes a protocol called Hypertext Transfer Protocol, which rigorously defines a way that computers could exchange bytes between each other, specifically for the purpose of transferring something called hypertext. But once they publish that standard, nobody is forced to follow it. And certainly, it takes a lot of work to author a standards document, and so I'm sure the authors of standards documents are often sad if their standard doesn't take off and become widely adopted in the internet. And so some standards have taken off and now shape the way that the internet works, and other standards have been written and abandoned over the years. The overall goal of the IETF is to make the internet work better. Its mission is to produce high-quality, relevant technical and engineering documents that influence the way people design, use, and manage the internet in such a way as to make the internet work better. These documents include protocol standards, best current practices, and informational documents of various kinds. The technical and engineering documents that are referred to here are the very same RFCs. Have you ever heard of JSON? Or YAML, or HTTPS, or URLs, or DNS, or pretty much any web technology that you can think of? These are all standards. And for example, something like JSON is very important that everyone does consistently, right? So it makes sense that there should probably be a source document somewhere that sets forth exactly what JSON is. You know, like a JSON value has got to be an object, or an array, or a number, or a string. And that way, if I am going to go and implement my own JSON parser from scratch, as long as I reference the source documents where the standard of what valid JSON consists of, I can trust that my tool will be interoperable with anyone else who writes tools that work with JSON. You know, like browsers and websites and REST APIs. And now it's possible that for something like JSON or YAML or HTTP or TCP, you could roughly learn the intuition behind these tools and maybe how they work from second and third degree sources like blog posts and books and conferences. But those sources are almost never reviewed by the original authors of the standard, and therefore there aren't as many processes in place to stop those sources from being incorrect, and also those sources are never going to be as thorough as the original standard specification. And the other side of that is, of course, these RFC standard documents are very long and dense, and so they can be a lot to parse. But they all have a standard format with a table of contents nicely broken down. And so these standard documents can definitely be a tool at your disposal to definitively resolve disputes about how to use web technologies or how you should implement web technologies. For example, you're implementing a JSON parser and you want to know what makes a valid string. Come to the string section of the RFC here and find that information. And now, of course, it is slightly misleading that I said that you can definitively resolve disputes using an RFC document, because largely you can for widely adopted standards like JSON. I mean, the whole world uses JSON at this point, and a lot of JSON parsers and encoders and libraries have been built up that are now used ubiquitously across the internet and its engineers, to where JSON as a standard is now cemented. And so, if you have a dispute about what valid JSON consists of, this document is a great source document to go and refer to. However, if a standard hasn't been so widely adopted, then who's to say that the RFC document really is the authority on how such and such web technology should be implemented? And in that case, the RFC document may be informative, but unfortunately not conclusive. RFC documents follow a lifecycle. First, there is an initial proposal. Somebody writes a draft of a text document like the one I just showed you for JSON and offers it to the community for evaluation. Then a period of exploring happens where it is decided that the RFC is worth pursuing, aka it doesn't deal with a topic that nobody cares about. Like if somebody came to me trying to propose a standard way to tie my shoes, my response would be, I already have a perfectly fine way to tie my shoes, and honestly, I don't see the value in having a standard way to tie shoes, because if everyone ties their shoes differently, as long as their shoes stay on their feet, we're all fine. Whereas if the proposal deals with something like HTTP, without which nobody is going to have an internet that's easy to use, then yes, I think there'd be a lot of interest there. Then the proposal is accepted, and it waits in this phase until someone actually implements it. For example, let's say the RFC deals with what is valid JSON. Then it's helpful for someone to go code up in some programming language a reference implementation of how to actually encode and parse some JSON. When implementation is complete, the proposal may be marked as ready for release, upon which it is reviewed and then potentially released. And then finally recommended, which is to say the IATF believes that it is now reasonable for the wider engineering community to adopt the standard, and now recommends that they do so. An RFC can also be closed or discontinued, which essentially mean that the RFC was rejected in some way. Okay, before we end this discussion, there are two more things that I want to tell you about RFCs. Recall that when I pulled up this RFC for JSON, I told you that if you ever have an argument at work about what valid JSON consists of, you can reference this document and win that argument. I already brought up weakness number 1 with that statement, which is that this is only valid if this standards document is considered authoritative, and that, unfortunately, is a fuzzy topic. But usually the document is considered authoritative if it is seeing wide adoption, and the community refers to it a lot. But another more technical reason why you can't just use this document as a source of truth for what constitutes valid JSON is that the RFC process allows for amendments, which come in the form of additional RFCs, which clarify, expand, or correct, or deprecate standards defined in previous RFCs. So for example, this JSON RFC number is number 8259, and it was published in December 2017. Well, a previous version of this RFC, 7159, was published in 2014 and described JSON somewhat differently. And this version of the document rendered obsolete to previous RFCs standardizing JSON. And you can see we go further back in time, and this one lands us at July 2006. These are examples of RFCs rendering previous RFCs obsolete, aka fully updating the standard, which is JSON, But new RFCs don't have to render previous RFCs obsolete. They can also simply expand to existing RFCs. For example, here is a 1999 statement of the Hypertext Transfer Protocol. In the table of contents of this protocol, there's a section called status code definitions. This is where the status codes for HTTP are formally defined, like a 200 response saying that a success was successfully handled, or 500 internal server error if something went wrong, or 404 not found if a resource that you're looking for isn't found. Well, if you've used HTTP much, then you can see that this list of status codes here is pretty short. I know for a fact that these are not all of the status codes that are considered valid for HTTP. Developer.mozilla.org has a much longer list. You can see that the scroll on the sidebar is a lot longer than the one that was defined in the document I just showed you. For example, the 500 error status codes stop at 505, whereas this list stops at 511. Let's click on one of these status codes from this list. And I did a text search for RFC, and check it out. Here's RFC 6585. And what do you know? Here's another RFC called Additional HTTP Status Codes, proposed in April 2012. Also, no surprise that Roy Fielding's name also appears on this document. What can we make of this? Well, basically, the full definition for any given concept when it comes to the web, for example, HTTP or HTML or JSON or YAML, and many other programming concepts that you've probably worked with before, that technical edition probably is not defined in a single RFC document. The full reference probably comes from the union of many RFC documents. And all of this adds up to a lot of text, and so it can be hard to parse. And so I think we can end the discussion saying, if you ever need to implement a standard at the absolute lowest level, for example, you're implementing your own HTML parser that needs to handle every case in the HTML specification, or JSON, or YAML, or you're writing your own browser, which works with HTTP. If you're working to that level, then you need to work from RFCs. Which even that technically isn't true because, larger companies have willfully resisted adopting RFCs in an effort to influence the standards themselves. Because remember, a standard is what people actually do. So it's one thing to theoretically define a standard, but at the end of the day, programmers aren't going to use the theoretically perfect version of JSON if there aren't libraries readily available to use it. For example, does the standards development organization behind CSS really define what makes CSS valid? Or is it Google who defines that because Google controls the Chromium browser, which handles most of the browser traffic on the web today? So yes, try to ascertain if the standard is actually respected. But if it is respected and you're implementing a web technology from scratch, then RFCs are what you'd want to reference. And not only that, you have a body of RFCs that you may need to be referencing. If you're more of a normal person with more ordinary use cases, there often exists more user-friendly consumable resources that make their best effort to do the work for you of consuming all of these RFCs and unioning them together into an up-to-date set of documents that cover the standard or the protocol in a more user-friendly way. All right, I hope you enjoyed this discussion of RFCs and the Internet Engineering Task Force and the overall process of how they and other standards organizations attempt to guide the development and adoption of technologies on the web in a way that works the best for many people. The process of drafting and accepting RFC documents is widely used in the software engineering industry. For example, the Python language has the Python Steering Council, and they write PEP documents that follow a very similar lifecycle, proposing and then accepting and then implementing changes into the Python programming language itself. Most other programming languages have a similar process. Hardware design follows a similar process. And even down to single engineering teams within tech companies will often use a proposal process to allow team members to propose ideas and hold discussion in a structured way and then record what decisions were made. For example, to standardize on what front-end web framework you use, or what the architecture of a particular project should be and why, and how we should approach security, and so on and so on. As you progress in your career, knowing what RFCs are and when to refer to them and when not to, and how you might even use a process similar to the RFC proposal process on your own team is really valuable and will help you understand when to trust blogs or books or team members on their opinion about how a certain technology is supposed to work and when not to. And now that we've had this deep discussion about RFCs, we can get back to our topic of HTTP and REST. So take a break, and whenever you're ready, join me in the next one.